Hello everyone, this is grade 6, module 1, lesson 23, problem set. Today we're going to be using rates again, and we're answering a few scenarios. So I'm going to do, let's say 1, 2, and maybe 5 and 6 here. So here we go with 1, and it says, who walks at a faster rate? Someone who walks 60 feet in 10 seconds, and I'm setting it up as distance over time, because remember, our formula is rate, yeah, that's right, rate equals distance over time, or distance divided by time. So we're trying to find the rate of this. So I have 60 feet in 10 seconds. My other one says 42 feet in 6 seconds. So what I need to do for these is I have to divide these out. So when I divide this one in red, 60 divided by 10 will get me 6, and then my units are feet per second. And I can write those as feet over second, like that, or I can write it out as feet per second. And what I'm going to do is write an abbreviation of FPS, feet per second, just so I can save a little bit of space. So my other one, over here, I have 42 and 6. 42 divided by 6 is 7. And then I have feet per second. So the question was, who walks at a faster rate? This person does, because they're walking a foot further per second. So let's go to 2. We're going to do 4 of these. So 2 says, who walks at a faster rate? Someone who walks 60 feet in 10 seconds, or someone who takes 5 seconds to walk 25 feet. So this one is worded a little differently, but it's still similar to the same thing. So we have a 60 feet per 10 seconds. And remember, when we're trying to figure this out, we're doing rate equals distance over time. So distance is going on top. For the other one, it says 5 seconds to walk 25 feet. I'm still putting 25 on top and 5 on bottom, because feet is my distance and it has to be on top, and time is in seconds, so that has to be on the bottom. So when I divide these, 60 divided by 10 is still 6 feet per second. That's based on the last question. I have 25 divided by 5, and that's 5. And again, I have feet per second. So to go back to my question, it says, who walks at a faster rate? This person, because they're walking an extra foot per second than the other person. So that's 2. And let's let's go. I'll go down to 5. I want to make sure I hit a nice blend here of a few of them. So let's go to 5, and it says a striped marlin can swim at a rate of 70 miles per hour. Is this a faster or slower rate than a sailfish, which takes 30 minutes to swim 40 miles? So the first thing I'll do is I'll write down the marlin. It can swim 70 miles in 1 hour. And the sailfish, and again I had distance over time, the sailfish 40 miles in 30 minutes. And I have an issue here with this because I need them both the same unit. They both are showing time, but they're not the same unit. So what I want to try to do is get them to the same unit. Since this one is out of a unit rate for hours, or a rate for hours, I'm going to try to get this one into hours. And I know that 30 minutes is half an hour, so that's going to equal 40 miles for a half hour. So I'm switching it over into hours. I'm converting 30 minutes to an hour. And now I need to divide. So 40 divided by 5/10. And I could have done this as a fraction as well. Half, which would have done 40 divided by a half. And I know that I need to go 40 times 1/2. I'm going to invert that. So I got 80 over 1, which is 80. And then I have miles per hour. And now that I'm looking back at this, I could have easily taken 30 minutes and said, well, if I double that, I'll get 60 minutes, which is 1 hour. And if I double my 30 minutes, I double this. So this question says, which is it faster than the sailfish? And I'm going to say no. And I'll say sailfish is faster. And I have my work to back that up. Let's take a look at the last one. This is 6. One math student, John, can solve 6 problems in 20 minutes, while another student, Joaquin, can solve the same 6 math problems at a rate of 1 problem per 4 minutes. Who works faster? So for this problem, again, I'm going to do, we don't really have a rate equals distance over time, but I do see that we have 1 problem per 4 minutes, and this other student is 6 problems. Let me do this in a different color. 6 problems in 20 minutes. So what I'm going to do is actually divide these out. So I'm going to do 1 divided by 4 here. And I have 1 divided by 4, and I know that this is going to get me into my decimals. And I see I'm at 25 hundredths. And it would be 25 hundredths problem per minute, or problems per minute. And you'll definitely want to write out that unit. Again, I'm just doing this to save myself a little bit of time, but you should write out problems per minute. And then when I divide this one out, 6 divided by 20, I see that I'm going to get 3. So 3/10 problems per minute. So which one is working faster? And if I can't see this because I went 2 decimal places there, I can always add 1 there as 0. So 25 or 30, really, we're looking at. And these are decimals, so it's 25 hundredths or 30 hundredths. This is faster because of my conversion there, and because I added that 0 to make it the visual look of it. But really, it's 3/10. This is a person who's working faster because they're finishing more of a problem per minute. Hope this helps. Thanks for watching, and good luck on the rest of your problem set.